I'm James Falkner, Community Manager. I also dabble in various things like the mobile app that I develop and maintain for our events, which you guys are all using. So all of those really annoying pop-ups you're getting from iBeacons, that's me. Um, we did a lot of development on that app, and there's a lot of technologies involved. And so I want to talk about how it's built because it uses Liferay as a backend, but it's not written with Liferay. So I want to show you guys some demos of how you can build hybrid mobile apps using Liferay as a backend, as a platform for your mobile apps, as part of a larger mobile story. So if you have mobile websites, you have mobile apps, all of them can be built on top of Liferay as a core technology. So first question, what is a mobile app? And I noticed Bruno Farash just walked in the room. So Bruno, if you were here last year, Bruno had a very, very excellent definition of a hybrid mobile app. It captures, people say pictures are worth 1,000 words. Well, this is worth 2 words. So, so thank you, Bruno. This is the last year I'll be reusing this image, but it's a really great description. You get the best hairy man and you get the best fast horse put together. Great app. So hybrid apps. There's lots of, when I say hybrid, that means different things to different people. So we kind of consider apps on this spectrum of full native and full non-native or mobile web. And in the middle is where hybrid apps live. So these are apps that have a UI that's cross-platform. They can access the native characteristics of the device, all of the native characteristics of the device, not just some. They exist on an app store, so they're discoverable through traditional means, traditional app store means, I should say. And recently, people have started to characterize them as quote unquote disposable apps, which I don't really like that word because it kind of implies it's not very useful of an app. It's very useful. It's just depending on the context of the app. So in this case, when you guys leave this event, you'll probably uninstall the events app unless you're going to other Liferay events throughout the year. Vast majority of you are going to uninstall the app. In addition, you didn't come to this event to play with your phones. You came to this event to listen to sessions and meet people. So this app is sort of considered disposable, but it's still extremely useful for its intended purpose. It's also mid-range in terms of cost. Full native is much costlier. Developers are they charge more per hour to develop for iOS and Android versus somebody developing a website. So these are the different kinds of native apps on that spectrum. For hybrid apps, there are many different choices of framework. Well, you can see them all, and there's more. There's probably more. This is probably almost a year old now, so there are many more hybrid cross-platform tools that you can use to build these apps. So then the natural question is, right, which framework should I use? I do not see Olaf in the room, so I will bring him. Olaf, which framework should I use? What's the right solution? It depends. Olaf, what's the right solution? It depends, right? There's no one answer, and that's why we're here today. So there are different reasons why you would choose to build a hybrid app. And here are the reasons why people chose a cross-platform tool to build their app. Why did you select a cross-platform toolkit? Number one answer, because it's cross-platform, of course. It's available across all platforms. 68% of the people polled said that. That's kind of obvious. Development speed, how quick is it to learn this new technology if it's new? How much native access do I get? How fast is it? Native, does it line up with the native look and feel? So all of these reasons are reasons you should consider when you're trying to decide which of these frameworks you want to use. Okay, so again, Olaf, it depends. So what kinds of mobile apps can you build with Liferay? Of course, you all know you can build responsive websites with Allo UI, HTML5, Bootstrap, all these wonderful technologies for building mobile apps, mobile websites. You can also build what we call dedicated websites. These are websites that are targeted to a specific device. So for example, if you deploy 15,000 Windows phones to all of your employees, you want to build a dedicated mobile website that's tailored to that specific device, either its size or some of its native features. You can also build full native apps using Liferay screens. You saw the presentation this morning from Jorge, or the screens demo from Juan Fernandez. So you can use screens. You can use mobile SDK to build full native apps. These are using Xcode, using Android Developer Toolkit, or using whatever the native SDK is designed for a particular device. And then finally, hybrid apps, and that's what we will be talking about now. So CPT stands for Cross-Platform Toolkit. Service Builder, you're all familiar. JSON Web Services, you're all familiar. This essentially means that Liferay is serving data to your apps, but not supplying the user interface itself. So some examples. Here's an example of a HTML5 hybrid app. This is an app written in HTML5, but also using Apache Cordova in this example. This is like the hello world, right? You include this JavaScript, you have an element that is of a particular class that receives an event. So when this is browsed on a mobile device, Cordova interacts with the native platform to send essentially events back and forth between your JavaScript that's running in your HTML5 code here. So you can have things like SVG tags and other kinds of HTML5 stuff. At the same time, you can have native access using Cordova or PhoneGap or any other native framework. Another example is there's a product called Sencha, and it's an HTML5, and it uses EXT.js as its base JavaScript platform. So instead of writing, inline JavaScript to rate your app, you kind of declare the model, the data model you use. It's an MVC framework, so you declare your views, you have models, and then you have controllers. In this case, you can see the view beginning here. You'll see a full example of this actually. So let me show you an example of what that looks like, hopefully. So if you've never used Sencha before, you can go and download it. I did that as well. I'll find it here. I'll make this bigger. So this is an app I built in about five or 10 minutes. It's got a GUI designer here, you can see. And the best part about this is it's HTML5, so you get a lot of different components over here on the left in their GUI builder. You can see a huge list. There's really cool charts. There are data models that you can adapt to your system, which is what we're going to do exactly right now. They have a Google map, which you can start to see at the beginning of. So let me show you how easy this is and how this is built. So the first thing I did is I defined a model. And my model is an event. So you've all used the events app for this event. This is kind of the poor man's version of that using Sencha. So I define a model, which is right here, a Liferay event. I've got 5 or 6 elements within my model: the title of the event, where it is, its longitude, its latitude. And then the question is, what's backing that particular model? In this case, it's Liferay.com, because that's where our data lives. We use dynamic data lists to store and retrieve data for the events. So that's what's actually backing this model. And so Sencha also has some really cool tools for defining that in what's called a store. They have this abstraction. So you define a store, you associate it with a model, and then you define how it sends and receives that data. So in this case, it's an AJAX proxy, which essentially proxies the data back and forth between Liferay.com. So if I click here, you can see the configuration. If I scroll way down here, you can actually see the URL I'm using here. So this is the URL to this web service, JSON web service on Liferay.com that we use, that the actual event app is using. Okay, and then it uses that URL, uses that backing to back the actual store that I've defined here in EXT. And then once I have the store, then I can start using that abstraction in other places in the views themselves. So I can define a view, which I've done here, which attaches to that store and displays the data from it. So this is my list, and you can see down here, I've defined it to show the LR events store. So the end result is this app here. I have a map, I have a list, I have a date picker. So I'm going to run this. I'm actually going to build this natively for Android and iOS and show you a couple things about it. So let me start the build because it takes a little bit of time. So while it's building, what it's going to do, it's going to build the app, deploy it to iOS, a simulator on this Mac, on my laptop, and to an Android emulator. And what I want to show you is the difference between what Sencha and HTML5 hybrid apps look like and give you versus something else, which we'll talk about in a moment, which is Titanium. So this should be done momentarily. And the other thing that that's very important to look at, so okay, that is the iOS, or the, so yeah, so this is the iOS version running here. You can see this is the list. So it basically, when this app started out, it went to liferay.com, built the models in memory, attached this scrolling list to it. And I have some event listeners as well that I wrote, very simple ones. So if I click on an event, it shows me some information about the event, and it changes the map to where the event actually is. So here's Darmstadt. And there's also a date picker up here. So let me show you what the date picker looks like. So this is one of the key differences here. So this date picker looks kind of like an iOS date picker. It's not. This is an HTML5 date picker. It looks the same whether you're on Android or iOS or mobile web or Tizen or any mobile platform, no matter which platform you're on. You can also, it's very, very configurable as well. You can change the spacing of these. You can make it thinner. You could change the font on the lettering, the names of these buttons and their colors, but it kind of looks like an iOS app. So let's look at the Android version of the app. It's running here. It's finally loaded. This is a tablet that's been scaled down. That's why it's smaller text. It's essentially the same exact app. And let me click on Darmstadt again, and you'll see eventually that we get something actually happens. This is the Android emulator is notoriously slow. So there's the pop-up about the event. Click OK. The map changes to show me the direction, and the date picker is updated. So if I click on this date picker and wait 5 or 10 seconds, it'll eventually pop up. And notice it looks pretty much identical to the iOS version. Same colors. But this isn't an iOS device. But it's exactly the same. So with Sencha, with HTML5 components, you get out-of-the-box components that look the same on all platforms and are highly configurable. You can change every aspect of that. So let's look at the next example, because this is where the key difference lies. So the next example is we'll use Titanium, and this is what the Events app is written with. So Titanium is also a cross-platform toolkit. It's another possible choice that you could use. And the difference here is it's kind of the same thing, right? You have code, there's something in the middle that bridges it to the native device. Pretty much the same concept. The major difference here is that when Titanium maps to native componentry. So when you see a date picker, it's going to look like an iOS date picker. When you see an Android, or when you're on an Android device and you click a date picker, it's going to look and perform like an Android date picker. So let's take a look, another example of that. So I have another very simple app that I've written in Titanium. It's extremely simple. It doesn't use any model view controller. It just kind of constructs a couple of buttons and some information about the app. Make this a little bit bigger. So this app is what it's going to do is download a list of blogs from a Liferay instance and display them in the app. So it's effectively, I have a login button, a username and password, and a go button. When I click go, it goes and downloads it. In this case, I'm using localhost. I actually have a running Liferay instance on this machine, and it's actually using the Liferay connector. So if you're not familiar with the Liferay connector, that's this code here, this lr.authenticate and session.invoke. So this is a very useful tool written by SMC in Italy. So they're a partner of Liferay's, and they're also a Titanium partner, and they've written a very, very useful, it's kind of like the mobile SDK, only for Titanium. So it's a cross-platform version of mobile SDK. It means I don't have to write all of the login code and all of this, the code to get at JSON web services on Liferay. I simply say liferay.authenticate, pass the username and password. If successful, go and grab the blogs and show them. And that's all this app does. And again, it's written in Titanium. Titanium is JavaScript based. So let's go ahead and run this app, and I'll show you what it looks like. So first of all, watch how much faster it is. So I'll build the iOS version. And here it comes. This is the iOS version, and let me start the Android version so we can go off and have a smoke, or I don't know, do something. Okay, so start the Android build, and while it's building, let me show you the difference here. So This is my app. I'm logging in as Bruno and Bruno. That's my local user. I click go, and I get a list of blogs here. And it's nice smooth scrolling. I can click on a blog post. I can see the actual content of the blog post. And I have a couple of buttons up here. I have another date picker. So let me show you the difference here. So this is the iOS date picker. So it's actually much faster because it's the native component. So what does that buy you? This buys you approval from Apple, unfortunately, because they have this giant document called the Human Interface Guidelines, and one of those guidelines is date pickers should look like this. It's also very performant because iOS or Apple devices are highly tuned to the Apple software is written to work very well on Apple hardware, not surprisingly. And Android is a very similar situation where the manufacturers like Samsung, they optimize Android to work well on their devices. So this is really fast. So that's what that buys you. It gets you performance and native look and feel. What are the drawbacks? Drawback number one, you can't customize it. You can't do anything to this date picker. It is always going to be this width. The fonts are always going to be the same, except for if you set accessibility options in the phone itself. But there's nothing that your app can do to override these fonts, these colors, the speed of the scrolling, the size of each row, and so forth and so on. So if I then run this in Android, which it should be ready, hopefully. So I'll run the Android version here. It's a little bit faster. It's actually, I have to click my thing here because I forgot to set up the native or the fake keyboard. So let me log in as Bruno. Okay, next. Oh, sorry, go. Oh, that's not good. What did I mess up? I think I forgot my password is wrong or something. B R U N O. Go. Okay, so here's my blogs. Also notice this image, the icon is on the right. That's another aspect of native components because the list scroll in Android, the image is defined on the right. Go figure. So I click this. I can see the blog content. I can click choose publish date, and now I get the native Android spinner. So point being here that there's trade-offs no matter which platform toolkit you use. If you use Cordova, HTML5, Sencha, you get HTML5 components, which work everywhere, but which are not as performant as the native componentry, and also potentially don't line up with the interface guidelines of that particular component. And then with with titanium, for example, you get you get mapping to, okay. Oh, it maps to the native componentry of the OS, and so it's more familiar to users of native devices. Okay, so that was that demo. Okay, so then the next question is, what about HTML5, pure HTML5? You can use it if it works for you. You have to know the limitations and use those to decide whether it makes sense for you. Like if you need Bluetooth support, or you need to create background execution processes, you can't use HTML5 to do that, so you have to look for alternatives. The other issue with HTML5 is that it can lag native features. So for example, Apple released iPhone 5 and 5S with the fingerprint sensor. There's no support for that in HTML5. So it eventually is probably going to show up, but it doesn't show up on the day that Apple releases those particular features because they generally like to keep those proprietary and make extra money until it becomes so popular that there's such pressure to standardize. So HTML5 can work for you if it meets your requirements. If you understand the limitations, especially in terms of browser support. So you can see this grid here. Certain browsers don't have very good support for HTML5. Others do. So make sure you understand that before you go down that road. Okay, the Events app. So you've all seen it. So again, it's written using Titanium Accelerator. We use Liferay Web Services as a backing. The content, like the pictures and the descriptions and the times of events of like this session, those are the same exact, it drives the website as well as our mobile app. It also can asynchronously update itself. So like this morning when you're shaking your phone, looking silly in the audience, trying to get it to update, that forces a resync, but it will actually do that automatically every so often. It also works when you're offline, so it caches everything. I know there's support in HTML5 for that as well, but it's kind of limited in terms of size and types of data that you can store. We're storing a lot of stuff here. We're caching a lot of things here. And the user interface is built using JavaScript. There's no GUI builder that we use for this. This is all kind of handcrafted because we want it to be pixel perfect. Okay, as I mentioned, it's using Titanium. We use cross-platform APIs for all those spinner lists that you see, buttons that you can click in the device. Titanium exposes a lot of native stuff using cross-platform interfaces. Things that make sense across platforms, like geolocation and mapping and contacts. Every phone has a contacts list, every smartphone at least. They have the concept of social networks because it's on the web. And Titanium also has support for third-party modules. So if there's something in the native device you want to access and you don't have access to it through Titanium, you can get a third-party module. Like when you scan your badge, that's a third-party library called, can't remember the ZXing. I can't remember how they pronounce it. It's odd. But yeah, that's used for QR codes. iBeacon support is a third-party module for iOS and one that we wrote for Android. And also the SMC Liferay connector is also open source and a third-party module that we use with Titanium. So what does it look like to build this process? So you saw some JavaScript earlier. Step 0 is to write JavaScript. Step 1, Accelerator or Titanium takes that JavaScript, packages it with source files that represent APIs for Titanium. It turns it into an Xcode project, and then it invokes Xcode itself to build the final app. And that's what we then in turn submit to the App Store. So it is a native device. It is a native app. It's true native from the App Store's perspective. They don't know that it's written with a cross-platform toolkit. It looks like a native app. It acts like one. They test it as such, and they approve or deny, depending on how lucky you are. So again, I said it uses Liferay as a backend, so we use dynamic data lists. I'll show you an example of that real quick. JSON Web Services. We also use Expando. Does any here use Expando services from Liferay? Yeah, a couple of you. Okay, good. So you're familiar with that. Expando is a schema-less data base, so you can create columns and rows or create columns on the fly. You can create schemas on the fly, much like MongoDB or these other document-oriented databases or NoSQL databases. Liferay's had this for a couple years now. It's really handy. It's really handy for events because all of our events are different. So we use Expando to store data. We also use documents and media, also known as a document library, to store images like the speaker headshots and the images for the maps and so forth. So here's a quick example of a dynamic data list for the France Symposium that we had in Paris earlier this year. So if you're familiar with these, this is just a list of arbitrary content, arbitrary columns, and then we have, this is actually a list of, I think this is maps. Yeah, these are maps, like internal, like Salon des Familles and Salon Bonaparte. There are different rooms in the venue. So, and then that is then read by the app and turned into the agenda here. So we do the same thing for maps, activities, contacts, all the things you find in the app. So using dynamic data, or sorry, using web services, out of the box, if I were to make a call to Liferay and say, give me the content of this article, a journal article or web content article, this is what I would get. I would get a huge unparsed XML file, which is 7,330 characters. Now that doesn't sound like a lot, but when you multiply that out by, we have 11 to 20 events per year. We have, I don't know, 50 speakers. We have 150 sessions, you know, it multiplies very quickly. So all of this would have to be downloaded over the network and parsed, which would eat battery. You could probably cook an egg on your phone while you're trying to review the agenda if it was all in this. So this is too fat for us, so we need skinnier. So we have written a very simple plugin on top of journal articles and dynamic data lists called the Skinny service, Skinny web service, which essentially takes all of this nasty stuff, takes out all the pink stuff that you see, which is what we really want, and turn it into a JSON, a true JSON object that's completely parsed and ready to be consumed on the client side, in this case, the device. So we went from 7,330 to 1,172. That's a pretty good improvement. So we use this extensively for all of the data that's coming across the wire. And this is what it looks like. It's a service builder service with nothing in the database. We simply use Service Builder to generate the remote layer, the remote APIs for JSON and for SOAP. So we say local service false, remote service true. We have a namespace. We have no entity, or we have an entity, but there's no columns inside there. There's no finders. There's none of the stuff that you normally find. So it's very simple to build. Again, it wraps it ultimately makes calls into the dynamic data list API to return back the content, but it does so through these remote APIs that are automatically generated by Service Builder. And then we add a couple of additional things, like we make sure the dates are the same format no matter what, because there's different kinds of dates you can store within Liferay. And this is the actual source code. I would show you the full source, but we're getting close to being over time. So essentially in Liferay 6.2, we have a new annotation called access controlled. This allows you to create anonymous web services. Everyone asks me, how do I create this web service so that anyone can get at it? This is how you do it. You annotate it with access controlled, guest access equals true, and you no longer have to log in to access this. And then we simply pass in a record set ID. This record set ID is actually stored on liferay.com in the dynamic data list itself. So the first thing an app does when you download it is it has a hard-coded record set ID, one hard-coded record set ID that goes to Liferay, gets the list of events, and then within that data are the other references to other dynamic data lists. So that's how it works. So we pass the record set, we check permissions to make sure we only serve up guest permissions. We only serve up dynamic data lists you have access to. Then we generate a big array and we just return the Java array, and then Liferay takes care of turning that into a real JSON object and returning that back. So here's two examples real quick. So if I click on, this is the non-skinny version. Uh-oh, that's not a good sign. Am I offline? Okay, well anyways, the non-skinny version would return that ginormous this. Trust me, it's pretty ugly, and you've probably all seen it before anyways. So let's see if the skinny version works. Nope. I'm not sure why that's not. Those are just URLs, so I'm not sure what's going on there. Let's see. We'll try it the manual way. Okay. Yeah, I'm not sure. I think maybe my Liferay might be gone. Okay, well, we're going to skip that part because we're running out of time. So the skinny version returns the skinny version, and the non-skinny version is non-skinny version, clearly. Okay, we're almost over. Okay, so, okay, app strategy. So briefly, we HTTPS everything. Every time it downloads something, it uses HTTPS. You should all do this. There's really no reason not to. We cache a lot of stuff. We asynchronously poll so that if you're offline or if we update the app and we want you to get the new version, it automatically does that. We assume the network sucks, so we minimize the network traffic through the skinny web and the exponential backoffs that we do when things fail. We scope all of our events. Each event has a separate site on liferay.com, and so we scope the data using that. We sign all requests that result in writing of data. So whenever you send us a survey answer, you rate the session 10 for this one, of course, please. Or we record your iBeacon data. We will sign all those requests. We also use OAuth for accessing social networks like those that support it, like Twitter and Facebook. So I recommend you take security seriously, take privacy seriously in your apps. This has nothing to do with JSON Web Services. These are just some random stuff for apps. Make sure that you opt in for everything so that you ask the user before you store their data, or you let them know what you're storing or what you're going to do. Don't track people, don't track individual identification. Describe the permissions. So if you on Google Play, if you download the app, you'll see a huge list of permissions we require. We tell you up front what we're going to do before we do it. And then finally, Bluetooth. And I don't know if we're going to have much time here, but you may have noticed in the event that we have these little devices. If I can put my pointer on it right there. I went around and hid these iBeacons. Please don't steal them. They're in each room. Every time you walk into or out of the room, the Bluetooth LE support on your phone will notify the app. The app then pops up things saying, hey, welcome to track B, or, you know, thanks for attending track B session, James Falkner, blah, 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 please rate. So it stores that back on Liferay as well. Every minute, it tells us anonymously where your device is. And so we can use that data. We can visualize that data. And we actually have a partner company in the US that did this. Hopefully this one will work. Actually, I think I've already loaded it. Yeah, so they visualize the data. So here is the replay from North America Symposium of the different rooms in the event. Yeah, so you can see that the colors changing, showing you how hot or how cold each room is. So how this works is every minute that app will send the data back to liferay.com. They pull that data, they stick it in Pentaho, and they generate some fancy business visualization that looks a lot like this using those numbers in real time. So this is actually a real play, but I can show you the real time. I don't know if it's going to be super exciting for DEVCON, because it's kind of, yeah, so this is DEVCON. So over time, it goes every 5 minutes, so not exactly real time, but every 5 minutes you can watch this. It's a demo, but you can also graph the data. Instead of seeing that, you can see something like this. This is kind of fun. So this is the DEVCON data. You can see the different pings, how many people were in each region, track B, track C, track A. So we use this as event staff to say, okay, a whole bunch of people said they wanted to go to this event. No one showed up. Or a lot of people showed up and the ratings were terrible. So we probably shouldn't invite that speaker back. So we use this data. We actually absolutely use this data to make decisions about the next year. So it's very useful for us to see how people are moving throughout the event. Okay, so I think that's it. Yeah, so summary. Different kinds of hybrid app tools, different trade-offs for each. There's no one single answer. You kind of have to look at your requirements, what your developers know already. Like if they know HTML5 and JavaScript, then that might make more sense than doing Objective-C. Or if you have, you know, very little money, you might want to look for a type of developer that doesn't cost as much, and choose a tool based on that. So last slide. So mobile slides or mobile sessions for tomorrow. So there's the Juan Hidalgo is doing a UX revolution about Liferay's user experience, which applies to mobile. Jose Navarro is doing a workshop on Liferay screens. And then at 2:30, Pierre Paolo Ramon is just in the back of the room, is doing an actual workshop on hybrid apps with Titanium. So the simple Titanium apps that you saw me building, you can do much more interesting things in his workshop. So I highly recommend you attend that workshop. So I know we have no time for questions, so thank you very much. I'll be around all day and all day tomorrow, so thank you.